Welcome to Unique Beam. In this video, we embark on an astronomical journey to one of the most fascinating and visually striking features in our night sky, the Orion Nebula. Located in the well-known constellation of Orion, just below the three stars that form the Hunter's Belt, this nebula is not only a spectacle of cosmic beauty, but also a dynamic cradle of star birth. It's here in this luminous gas cloud that new stars are forming, shedding light on the mechanisms that shaped our own solar system. Billions of years ago, the Orion Nebula, also known as M42, is one of the closest star-forming regions to Earth, making it an invaluable window into the stellar and planetary formation. Its bright glow and distinct features allow astronomers and scientists to study aspects of the universe that remain hidden in more distant reaches. Join us as we explore the depths of the Orion Nebula, uncovering the secrets of its stellar nursery and the dynamic processes within that foster the birth of stars and planets. The journey of understanding the Orion Nebula began long before modern telescopes. Its fuzzy glow was noted by many ancient civilizations. However, it was not until the invention of the telescope that its true nature began to be understood. The nebula was first observed with a telescope by Christian Huygens in 1656, and since then, it has been a focal point for astronomers around the world. Its relatively bright appearance and detailed structure have made it a prime subject for observational astronomy, offering insights into the complexities of nebular matter. Throughout the centuries, the Orion Nebula has been mapped and studied by some of the greatest minds in astronomy. Each observation has contributed layers of knowledge, revealing the nebula's intricate dance of gas, dust, and emerging stellar objects. These studies have helped to paint a detailed portrait of star formation, from the collapse of gas clouds to the ignition of stellar cores. The Orion Nebula is primarily a vast cloud of gas and dust, glowing intensely due to the ultraviolet light from the young, hot stars that have recently formed within it. At its heart lies the Trapezium Cluster, a group of bright young stars whose intense radiation lights up the surrounding gas, creating the nebula's iconic glow. The nebula is part of a much larger cloud known as the Orion Molecular Cloud Complex, which encompasses much of the constellation. This region is rich in hydrogen gas, the primary material for star formation, along with helium and trace amounts of heavier elements like oxygen and carbon, which are critical for forming planetary systems. The structure of the nebula is sculpted by the interactions between these materials and the stellar winds from newly born stars, which carve out cavities and create complex filaments and streamers of gas and dust. The process of star formation within the Orion Nebula is a spectacular demonstration of the interplay between gravity and thermal dynamics. Within this nebula, vast clouds of hydrogen gas begin to collapse under their own gravitational pull, a process that may be triggered by the shock waves from nearby supernovae or the tidal forces of passing stars. As these gas clouds collapse, they fragment into smaller clumps, each potentially forming a new star. Within these clumps, the material at the center begins to heat up as it becomes denser, eventually forming what is known as a protostar. This early stage of a star's life is crucial as it sets the foundation for all subsequent evolution. The protostar continues to accrete material from its surrounding disk, growing in mass and temperature until nuclear fusion ignites in its core, marking the birth of a new star. Before we continue to explore the fascinating life cycle of protostars in the Orion Nebula, this is the perfect time to become part of the adventure. If the mysteries of star formation captivate you, be sure to subscribe to Unique Beam and give this video a thumbs up. Your support helps us unlock more of the universe's wonders and share them with you. Now, let's dive deeper into the evolution of these young stars and the remarkable processes that guide their journey. As the nascent stars in the Orion Nebula transition from protostars to main sequence stars, they undergo various stages that are observable in different parts of the electromagnetic spectrum. T-Tauri stars, a class of very young stars that have just emerged from the protostellar phase, exhibit strong winds and rapid variability in brightness. These young stars are often surrounded by circumstellar disks from which they continue to accrete material. Over time, these disks may also coalesce to form planets, moons, and other smaller celestial bodies, mirroring the early stages of our own solar system. In the Orion Nebula, these processes are not only common, but are also critical in understanding stellar and planetary formation. The presence of numerous T-Tauri stars within the nebula provides astronomers with excellent examples of young stars at critical points in their development, offering insights into the dynamics of early stellar evolution and the factors that influence the formation of a stable star. The young stars in the Orion Nebula, particularly those in the Trapezium Cluster, play a significant role in shaping the nebula. The intense ultraviolet radiation and stellar winds from these massive stars ionize the surrounding gas, causing it to glow and sculpt vast cavities within the nebula. This interaction not only reveals the presence of young stars, but also helps clear away the surrounding gas and dust, allowing astronomers to observe these stars more clearly. Furthermore, the stellar winds and radiation pressure from these young stars can trigger the collapse of nearby denser pockets of gas, initiating a new round of star formation. This process, known as triggered or sequential star formation, suggests that star formation in regions like the Orion Nebula can be a self-perpetuating cycle driven by the very stars it creates. The dynamic environment within the Orion Nebula is also crucial for understanding planetary formation. Observations of protoplanetary disks within the nebula, made possible by advanced telescopes like the Atacama Large Millimeter Submillimeter Array, or ALMA, have revealed numerous disks containing gaps and rings. These features are indicative of planet formation, as planets emerging within the disk can clear paths and trap materials in specific orbits. Studying these disks within the context of the Orion Nebula provides invaluable data on how planets form in different environments, particularly in more crowded and active stellar nurseries. This research helps astronomers compare these formation processes to those in quieter, more isolated systems, and even predict the types of planets that might form around different stars. The Orion Nebula has been a focus for many telescopic campaigns that have pushed the boundaries of our technological capabilities. The Hubble Space Telescope has provided some of the most detailed and striking images of the nebula, revealing not just the chaotic activity of star formation, but also the delicate beauty of its gaseous landscapes. More recently, the James Webb Space Telescope is expected to offer even deeper insights, with its powerful infrared capabilities allowing astronomers to peer through dust clouds and see the earliest stages of star and planet formation. These observations are crucial for advancing our understanding of stellar and planetary evolution. Each new discovery adds to our knowledge of how complex structures in the universe form and evolve, and provides further context for understanding our own place in the cosmos. The Orion Nebula remains one of the most studied and celebrated objects in the night sky, a real-time laboratory for astronomers studying the processes that drive the birth of stars and planets. Its proximity and brightness allow us not only to observe these processes in detail, but also to appreciate the sheer scale and beauty of the universe. As we continue to explore this and other nebulae, we move closer to answering fundamental questions about the origins of stars, the formation of planetary systems, and potentially the conditions for life itself. Thank you for joining us on this stellar journey through the Orion Nebula. If you found this exploration enlightening, don't forget to subscribe to Unique Beam and like this video. Stay tuned for more cosmic adventures as we unlock the secrets of the universe together.